Welcome back. In this video, we are going to continue on with our series on properties, perimeter, and area. This time, as I'm sure you can see, we're actually going on with rectangles. So let's jump right in and have a look at the properties of our rectangle. These are all going to be very similar to the last video being a square. So what I'm going to go through first are really the similarities before the differences. And what they both have in common is that they have all four right angles. All four angles are right angles. They also have, again, two pairs of parallel lines. Except this time, the main difference that we have is actually two different lengths. So we've got the top one and the top line and the bottom line. They're the same length, and the two lines to the left and the right, they are also the same length. So let's write these out. Four right angles. We also have two pairs of parallel lines. Only now we also have two pairs of equal length sides. Okay? This is going to become very important once we get into perimeter and area, but very much keep in mind that these are two pairs of equal length sides. So the top one and the bottom one, they are the same. The left and the right one, they are also the same. So let's move on. As always, pause the video, write those down in your book. They will be very useful. Perimeter. So when we come to perimeter, again, we are looking for the distance the farmer would walk around the outside of the property. What is different here, though, is with the square, we had all four sides was the same, so we could just say side times 4. The rectangle is not quite the same. So what we find with when we are doing perimeter, we have a side here that we would call the length. And of course, this one down here is also the length. Well, this side over here needs a name as well. It's not going to be length because remember in math, same symbol means same value. And this side is not the same value. It is going to be different. So we need to give this one a different name. So we're actually going to name this one the width. And it is equal to this one here, so we are going to call this one also the width. Well, remember, perimeter, we want to find the sum total, the complete total of all the sides when we add them together. So we could say length plus width plus width. And you know what? You'll get there if you use this formula. You take 10 meters and 2 meters. If you say 10 plus 10 plus 2 plus 2, you'll get there and you'll get your 24 meters, which is the perimeter. But again, we're kind of looking at maybe shortcutting a little bit. If this formula works for you, then that's great, but we're going to try something new. And what we're looking for here is the fact that essentially we have two pairs. If we cut this in half, we have two lengths, we have two widths, so we can almost just double that value. If we take this length, bring it down here, and this width, bring it down here, we have length plus width. We're going to put those in brackets because we want to make sure that when we calculate, we do those first. But we have two of them. So it becomes length plus width times 2. Now, when we substitute in and we have our 10 plus 2 times 2, well, 10 plus 2 is 12 times 2 equals 24. It gets us to the same result. That's just one option. If you prefer to add all of those sides together and it works for you, it works for your processing, do it that way. If you would rather do length plus width times 2, do it that way. These are really just options for you, but that is perimeter of our rectangle. So let's move on. We now have area. And believe it or not, we're still going to use the same names on our shape. We still need our length and our width. Only this time, remember that length, or rather area, really came down to that grid. So we've got our grid overlaid on our shape. Ugh. They are very uneven, but that's okay. We can still work with it. We're still going to get our area from it. So remember, area for the square, we did side times side, and it would kind of imply that we're looking at this side times this side. But if we think back, we also remember same name, same symbol, same value. We don't have the same value here, so we have to use different symbols. And that's why we use our length and our width. Well, in our formula for a square, we did side times side. We're still going to multiply them. It's just that we're not doing side times side anymore. We're doing length times width. So if we put our values back in there and we say 10, or rather, how much do we actually have here? 1, 2, 3, 4, 5, 6, and 2. Our length is 6 times 2 will give us 12. We're not done yet, though. What was the really important thing that we had to put in to let the reader know that we're talking about area? And if you're thinking back and you're saying something along the lines of our units squared, you would be correct. Now, when it comes to volume, it's going to be it's going to be a new symbol, but for now we're looking at area, so it's units squared. Keep that in mind in the back of your head every single time. What am I working with? Am I working with values in a straight line? Am I working with units squared? Okay, I hope this has helped. If you've got any questions, please write them down, bring them into class. I'll bet your teacher up the front has a whole bunch of activities for you to get really good at this, and I will see you for our next video. Bye.